Good morning. I am Niranjan Nitin Patel from third year civil. My topic is concept of consistency limit. Definition: consistency limit is nothing but the water content at which the soil changes from one state to another state. That is consistency limit. The consistency limit of fine grained soil. It is the physical state at which soil exists. Historical background of consistency limit. Swedish agricultural engineer Atterberg was who only one that he was mentioned that a fine grained soil can be exist in four stages, that is liquid state, plastic state, semi-solid state and solid state. So consistency limits are also known as Atterberg's limit. Atterberg or consistency limit. So in consistency limit there are liquid limit, plastic limit and shrinkage limit. So the liquid limit, what is liquid limit? The liquid limit is nothing but the moisture content or water content at which the soil changes from plastic to liquid state. That is liquid limit. Then plastic limit, the moisture content at which soil it changes from semi-solid to plastic state. That is plastic limit. Then the shrinkage limit, the moisture content or water content at which the soil changes from solid to semi-solid state. That is shrinkage limit. So in this chart, when the water content is added, then soil changes from its state to solid to semi-solid, semi-solid to plastic and plastic to liquid. So that means when water content is added or when water content is more, then soil changes its state. Here is the graphical representation of consistency limit. In this graph, consistency limit, the water content is in x-axis and the total volume of soil mass in y-axis. When the water content is increases, then soil changes from its state to solid state, semi-solid, then plastic and liquid. So the soil, when the water content is added in soil, then the soil it changes their state and also its volume is also changes. Then determination of consistency limit. The consistency limit can be determined by following three tests. First one is liquid limit test, then shrinkage limit test and then plastic limit test. First one is liquid limit test. For this liquid limit test, we require Casagrande apparatus and this grooving tool. So short process, this is a very simple process in which we needed 100 gram of soil sample of 425 micron sieve passing through 425 micron sieve, then added a approximate water in it, then make a paste of it and level it and place in the Casagrande apparatus of depth of 1 centimeter. Then make a groove from this soil sample and rotate the handle at the rate of about 2 revolutions per second, and the number of blows are continued till the two parts come into contact at the bottom of this groove. By the alternating the water content of soil, repeat this procedure for 5 times at the range of 2 number of blows per second, 2 revolutions. The liquid limit is determined by plotting the graph of semi-logarithm graph. The liquid limit is determined by the following graph. The graph is we discuss in next slide. That is the water content corresponding to 25 number of blows shows the liquid limit. So here is a observation table where 4 different samples are taken of 100 gram. Then the amount of water content added in it, percentage of water content and number of blows represented by the Casagrande apparatus. Then this is the, from this graph, the different number of blows and water content are plotted by a single line, and at exactly 25 number of blows what is the moisture content we get, that is the liquid limit of that soil sample. Then second test is plastic limit test. For this plastic limit test, about of 15 gram of oven dried soil specimen we needed of from passing through the 425 micron sieve. Take it and mix thoroughly with the distilled water until soil must become a plastic enough. So here in this image we see we have to make the soil as a plastic state as shown in figure. Take a portion of a roll glass platform and we have to make the around 3 mm diameter of soil sample. When the diameter reaches 3 centimeter of soil, then we have to remold it into a ball. The process of rolling and remolding is repeated until the soil just crumbling. So then crumbling threads are kept for water content determination. We have to repeat this test with 2 more samples. Then in the observation, weight of dry soil is taken, then weight of empty container, weight of wet soil before drying and weight of soil after drying, that is W2. So for water content, plasticity index is equal to liquid limit minus plastic limit. Then shrinkage limit, our third procedure to determine the consistency of soil sample. For this test, we have mix up about 50 gram of soil passing through 425 micron sieve with distilled water to make a creamy paste which can be placed in shrink dish without any air holes. The required mixing water content is somewhere greater than the liquid limit. Coat a thinner layer of Versaline inside of the shrinkage dish and wet. Fill the dish in 3 layers by soil paste. The last layer should be stand above the rim. Wet the dish full of wet soil. We have to immediately dry it oven at 105 degrees Celsius to 1010 degrees Celsius. Remove the dry pat from the dish. Clean and dry the shrinkage dish and determine its empty mass. Then wet the empty mercury wet dish also. Keep the shrink dish in a large porcelain dish. Fill it to overflowing with mercury. Transfer the content of the shrinkage dish to the mercury wetting dish. Place the glass cup in a large dish. Fill overflowing with mercury and remove the excessive by pressing the glass plate. Place the dry soil pad on the surface of mercury and submerge it. Transfer the mercury displaced by the dry pad to the mercury wetting dish and wet it. Then for calculation and observation, weight of shrinkage dish plus soil weight, then weight of wet soil in shrink dish, then weight of shrinkage dish plus dry soil, weight of the dry soil pad, volume of wet soil minus volume of shrink dish, that is V1, and volume of the dry soil pad V2. For shrinkage limit, here is the formula, that is Ws is equal to W minus Ws minus rho W V1 minus V2 divided by Ws. And for the shrinkage ratio, Ws divided by V2 rho W. And for volumetric shrinkage, here is the formula of V1 minus V2 divided by V2 into 100. So importance of Atterberg's limit. If we know how to get water content of our sample relative to Atterberg limit, then we already know that great deal about the engineering response of our sample. So we have already known that what is our water content of our soil sample. Then the Atterberg limit are water content at certain limits of critical stages in soil's behavior. The Atterberg limit along with the natural water content are the most important items in the description of fine grained soil. Then Atterberg limits are used for following general applications. The obtain general information about a soil and its strength, compressibility, permeability, shrinkage and swell properties. So the Atterberg's limit or shrinkage limit is helps to know soil's strength, compressibility, permeability, shrinkage and its swell properties. It is used in empirical correlation of engineering properties. So what are the different engineering properties of soil? We will know by the Atterberg's limits. For soil classification, so for the it will helps to classify the different soils by the Atterberg's limit. In construction specification, so in the foundation purpose, so for the site soil classification and for soil testing of site, the Atterberg's limit or consistency limit will be helpful for construction purpose. Thank you very much.